What's happening, folks? Geologist Philip Prince talking today about this crazy landscape, the Llano Estacado and the Panhandle of Texas, absolutely covered in these little playa lakes. Kind of tough to see them if you don't have Lidar imagery like this. If you do have Lidar, particularly if you can exaggerate the elevation a little bit, they stand out very nicely. Really fascinating landscape. There's sort of not anything else like this in the continental United States. I don't think. This is a little bit northeast of Lubbock. Give you a sense of where you are in the overall state of Texas. It's a pretty big place, right at the end of the yellow arrow there. So these features go for miles and miles in any given direction from this image. Give you a sense of the size of them. They're actually pretty big. Each one of those little depressions is thousands of feet across. I'd say the average one in this image is something like 4,000 feet across. It'd be like 1,200 meters across. The line I've drawn on there is just kind of a random scale bar that goes from end to end across a set of these little guys. And again, pretty unique within the continental U.S. When I say they're hard to see without LiDAR, kind of get an idea of what you're looking at here. There's a lot of agricultural use here with these circular or radial irrigation patterns. But within that is where you find the playa lake. So the agricultural stuff here doesn't actually have anything to do with what you're seeing in LiDAR. If you see the pointer right there, there's a little bit of bright white color, that's sand on the rim of one of the playa lakes. And that's actually a good way to try to find them when you're just looking at the aerial imagery alone. If you go back, a lot of times there's a little bit of water in the middle of them, depending on the time of year that the picture was taken. And if there's no water there, it might be a little bit swampy, and in fact be too swampy to use for agriculture. So these things impact land use. And they're also pretty significant to groundwater, because when water collects in them, slowly but surely it filters down through the layers in the base of the depression and charges up the aquifers underneath. Now, an interesting detail of these is that they have popped up in the great Carolina Bay debate. What are Carolina Bays? If you watch any videos on my page, I would tell you they are some expression of Pleistocene climate. A lot of folks are on the impact side of things. And the very landscape I'm talking about today actually has shown up in one of the Zamora videos about impacts and things like that. Interestingly, these playa lakes got dismissed as having anything to do with the whole thing, and this is how they're presented in that video. It's a very colorful image, but it's in fact so colorful with the elevation classified like that, you can't actually see what the landscape looks like. And if you look at the captioning down here, indentations, they don't have elliptical geometry like most Carolina bays. I'd agree with that. They don't have raised rims. I would very much disagree with that, because you can look at them in this image zoomed out and see that there certainly is a raised rim, typically on the southeastern side of the playa lake. This one shows up very nicely. The color there is a little bit different. That's because it's higher than the surroundings. I would say the top of this rim is probably 40 or 50 feet higher than the very base of the depression. It's about 15 or 20 feet higher than the surrounding landscape outside of the depression. And don't really get a sense of that just looking at the aerial imagery. There is a little bit of bright coloration. You can see that maybe the soil is a bit sandier there. This playa lake here, again, is like thousands of feet across. So you're looking at 15 or 20 feet of elevation change over the full scale of the view here would be miles. So it would be very, very difficult to perceive that, but there would indeed be a rise in the landscape there. So raised rims are present on a lot of these playa lakes, as they are on Carolina bays, which you'll see momentarily. Zoomed out here again, we'll throw on a scale bar of the same size as earlier. Tons of these things. This is west of Lubbock this time, and the landscape's absolutely covered in them. And most of the bigger ones will have that dark shadow on their southeast side where there is a raised rim, which is presumably just piled up sand that has blown up and out of the margin of the playa lake. Pretty interesting detail about them is that they tend to line up. And you can't really tell from aerial imagery unless you're looking really close, but with LiDAR, very plain to see that they tend to kind of like line themselves up in the landscape. And in this case, it's northwest to southeast. I've got a little pale yellow line there to give you a sense of what I'm talking about. So you got a line of them there, another line of them there. I think this is some kind of an airstrip here. This isn't the Lubbock airport. We zoom out even further. This black box shows you the general area we were just looking at. That alignment becomes even easier to see. So there are, literally sort of like strips or trains of these things dotting across the landscape. That's interesting to me. When I first saw these on Lidar, that was what caught my eye. And generally, if you see depressions lined up in the landscape like that, that means they're karst, or they're somehow related to material dissolving underground. I'm going to talk about that in a minute as well. These are not your typical karst features, if that is actually why they are there in the first place. But it's useful to look closely at them, actually, if you want to think about whether or not they have anything to do with material dissolving in the subsurface. And going back to those raised rims, if you look at the raised rims, a lot of times they overlap. There's a couple examples here. The ones I'm pointing out there are the best. And these rims are sort of draped on top of each other, and there are 3 depressions there that actually sort of like stack on top of each other, if you want to call it that. If these features were related to sinking of the landscape alone, this particular setup of overlapping rims would not be possible. Now, if you look at the rim here on the left, yeah, it kind of dips down into that depression, but it fully does go across it. Now, you could say, well, this collapse here formed after that raised rim did, and that would be a reasonable question to ask. In this case, however, with this big raised rim going across 2 of them here, you can't have that set up and have these being totally related just to sinking of the landscape. Now, why would there be raised rims on the same side of all of these? Easy answer: prevailing winds. The wind would blow in from northwest to southeast, hit the raised margin, and blow sand up and out of it when the Playa Lake is dry. They're only filled with water, and I don't even think they fully fill up. They have water in them for portions of the year. It's weather specific. Looking at them again with aerial imagery, they're different than their surroundings. A lot of them can't quite be farmed, but some of them also can be farmed, and they just end up being depressions that will carry water for a period of time during the year. The raised rims are something you can look at with Google Earth if you want to kind of prove to yourself that they're there. Again, the LiDAR does a really nice job of showing you that, but you can use Google Earth overlay and draw a little profile line across it. And if you look down here at the profile there, you're going across the Playa Lake. There's that raised rim, and then it flattens back out again. Now, this is massively vertically exaggerated. The height of the rim there, again, is like 15 or 20 feet, so 5 or 6 meters above the surrounding landscape. But it certainly is there, and it's something that you see as well. If you look down here on the right in Carolina Bays. So I've got Carolina Bays from Sumter County, South Carolina. There's the Playa Lakes from just northeast of Lubbock. And they kind of look alike. They both have a raised rim, and they actually share a number of geologic or contextual features. Closed depressions with raised sandy rims. Most of the bays in South Carolina are wet and have standing water year round. I'm not sure if that's the case for any or I guess most of the Playa Lakes. I know some of the salt lakes out there that are a little bit bigger have water year round, but water collects in the depressions. They're formed in unconsolidated sediment. There's not rock underneath them or anything like that. It's sediment layers, and specifically there's a little bit of clay exposed in the bottoms that helps them hold water. They form in wind sculpted landscapes. The dunes that you see there in the South Carolina shot are really, really nice. You don't see that develop quite as well east of Lubbock, but if you actually go into to eastern New Mexico on the Llano Estacado, there's some very nice dune features that develop around the Playa Lakes. And Pleistocene age. I think if you pull sediment cores out of those Playa Lakes, they've been collecting water, I think, and sediment since the Pleistocene, which is something similar to what you see in the Carolina Bays as well. Plenty of differences, different size and shape. There are exceptions to that. Talk about in a moment. Different substrate and geologic setting. Coastal plain sediment there in South Carolina. In Texas, you got unconsolidated sediment on top of like a caliche type of soil, which is sort of like a hard pan. It's not soil like we have on the East Coast, kind of an arid climate thing. It is prone to a little bit of dissolution. So in other words, it's possible for the material under the surface sediment to dissolve some in the Llano Estacado, and that might indeed be how you could get these depressions started. So that's an interesting thought. Playa lakes also have the different alignment patterns. You're never going to see this big, long, tens of miles long line of them in expressed in any way in the Carolina Bay settings. Bays do cluster and appear to line up. It's a different looking kind of thing. The playa lakes are also really big compared to Carolina bays. Everything's bigger in Texas, no exception here. The longest bay in my little Carolina Bay image here, this nice long, really elliptical one. You can look at other ones here and see that they're almost round in shape. So there's a lot of variation in bay shape, but this big, long elliptical one is something like, it's like 3,000 feet in its longest dimension, maybe like 3,500 or something like that. It would actually fit inside one of these round playa lake depressions here. So I've tried to zoom those images so that they kind of match up in terms of scale. Suffice it to say that pretty good size Carolina bays approach the scale of the playa lakes, but quite a few Carolina bays are smaller. Now there are plenty of Carolina bays that are bigger than the average playa lake as well. But generally speaking, and certainly in this image, this is in Marlborough County, South Carolina, so kind of like the northeastern coastal plain. Bays there are a good bit smaller than the playa lakes. And talking about shape, if you zoom in on that South Carolina image, yes, there's a lot of variation in shape. Some of these are quite round, some of these are quite elliptical. That shape varies quite a lot. You see that really anywhere you look at these on the Atlantic coastal plain. With the playa lakes, on the other hand, most of them are quite round and almost conspicuously so. Here's some nice round bays. This is in Accomack County, Virginia. This is like out on the Delmarva Peninsula, so the east side of the Chesapeake Bay. Nice round bay there. Really cool elevated sand rim on this one that looks quite a bit like what you see on a playa lake there. And that bay is 2,300 feet across. So if you drew it into a playa lake, it would like look something like that little black line. It'd be half the size of the playa lake or something like that. So physical scale differences are a big question. Now, thinking about the sinkhole idea and whether or not the playa lakes have anything to do with material dissolving under the surface, that's something worth thinking about, and that's why I said alignment is important there. If you look at this image of sinkholes from Wythe County, Virginia, down here in the right, you can see that there are lines of these little pinprick depressions running across the landscape. Those are sinkholes that have developed in limestone and dolomite bedrock. And because of the geometry of that bedrock underground, both the layering and the fracturing, it's controlled by these layers having been squeezed and folded. You get straight lines in that, you get geometric shapes, and the sinkholes follow that. You see that with the alignment of the playa lakes, but again, they're, among other things, just really, really big. And I'm not sure what the structural details within and below the caliche down underneath the sediment on the surface there that the playa lakes form in is actually like. Since a scale here, there's another random line drawn across a few of those playa lakes. That line is about 3.5 miles long. You can't even fit that line in this Virginia image. You're only seeing like 2 miles of landscape or something like that. So each one of those little sinkhole depressions in the Virginia example is so physically small. Like, I mean, it wouldn't even be any point to try to draw it within one of the playa lakes. So just a totally different sense of physical scale. That raises the question, if those aren't totally collapse features in the Texas Panhandle, what are they? A lot of people would tell you they started as wind only features. They started as deflation hollows, where some detail of the wind, turbulent shape of the ground, whatever, starts to scour sand off the surface. That exposes the clay underneath, and then water can fill in that depression and be trapped on top of the clay. Another alternative hypothesis would be that, yeah, there was a little bit of dissolving of material well below those sand layers. They sag down because of that. That depression starts to catch water. When wind blows on it, it pushes waves around, and that sort of allows the Playa Lake depression to expand and sculpt the landscape around it. Hard to know, but it's very difficult to compare those to any kind of karst feature. Certainly in the Appalachians and in any part of the Appalachians. I got an example here. This is close to Waynesboro, Virginia, and there are some nice round depressions in the landscape here. This one's different because there's a blanket of sediment. In this case, it's like sand and gravel that sits on top of the bedrock that's dissolving to make the sinkhole. So the sand and gravel has to collapse down as a result of what's going on underneath it. And you get these nice round depressions. Notably, they don't have any kind of raised rim on them. They're also really little, just like a few hundred feet across. I've looked all over the Appalachians. The biggest perfectly round sinkhole you see anywhere, and the disclaimer there is that in Appalachia they're going to be very much bedrock and like what I would call like hard, mechanically strong bedrock controlled. The biggest ones you see are like several hundred feet across or something like that. If you get a solution related depression in Appalachia that's more than a few hundred feet across, it's not going to be perfectly round. It will start having like angular sides that are like a reflection of structural weakness in the bedrock. So the perfect roundness, there's a limit on the physical scale that you see from that. Again, at least in the Appalachians, and it falls short of Playa Lakes by something like a factor of 10 or something like that. So when you're looking at these things, man, they're big, they're weird. There's so many of them. The way the pattern looks like, I look at Lidar all the time, and it's hard for me to look at this image because it inverts. I don't see them as depressions always in this image. Sometimes they look like raised humps when you use the black and white. And a lot of times, if you start seeing that, you just have to get rid of the image and open it up again so you can see them as depressions. So they're a very unique landform, and the small scale details, in addition to their overall size and alignment and everything else, is really interesting when you're trying to think about what they might represent. So, I don't know what to tell you. I've read material online about them. A lot of people favor like a wind only origin for them. Other people would say that there needs to be a little bit of dissolving of material underneath the depression to start the process. But when you get these raised rims and everything, you know that wind and the loose unconsolidated sediment that they formed in is certainly a part of their story. But whether or not they have anything to do with similar features in Iowa or Nebraska or the Carolina Bays on the East Coast is a good question. Anybody's guess. Really cool to look at these in Google Earth. Try to move this slowly, and every time I move Google Earth with a screen recording, it tends to kind of lag and jump around. But I wanted to show what the elevation profile tool looks like here. So we'll take one of the lakes we looked at earlier, get the little ruler there, and we'll draw a line across it. Save that, don't care what it's called, and show elevation profile. And as you move the pointer across at the top of that sander, it's like 3207, and it drops down to like 3198. So that's like, it's like 9 or 10 feet tall or something like that where we drew it. But it's very much there. Otherwise, you got a big broad depression, and that elevated rim it's not something that you see on every single one of these. Like there's a Playa Lake up there that's quite small that doesn't have the rim, and there may be like a threshold size and depth and exposure that's necessary to actually blow the sand up and out of there. Really cool features. And again, I've sort of stumbled onto these looking around on a LiDAR map the other day. I'd never seen them before. And what in the world's going on? It's tough to like figure out what something like that is. if you Google search depressions in Texas Panhandle, something like that, you're not going to really find anything. So slowly but surely, I found out that Texas playa lakes is what you had to search for, and because they recharge an aquifer, migrating wildlife tends to stop at them. Place that is not just absolutely overloaded with surface water, to say the least. Anything like this that does capture water and put it back in the ground, it's pretty significant. So there has been a lot of study of these. If you want to look at them on your own, like I try to show in a bunch of these videos, you can do that. Go to Google National Map Viewer, click on that link. That's the one you want. You want to launch the viewer, get the waiting screen here. Waiting. There we go. You want to go to layer list. And like the Carolina Bays, to be able to see these playa lakes, you've got to select hillshade stretched. And that's going to exaggerate the topography and the landscape a little bit. We'll go to Lubbock here. You can go to Amarillo as well, and plenty of other places. And as soon as that screen pops up, there they are. Yeah, can you find any? There's a few in there. Be fun to try to count them up. Tens of thousands is the estimate I see. Really, really significant landform, and a really interesting contrast to kind of the gullies and like arroyos here that are in the edge of the cap rock there on the Llano Estacado. So a really cool landscape. One that's worth checking out. Of course, you can do this just from a web browser. Give a look at it, see what you think, and then take yourself back over to the Atlantic coastal plain and look at some of the Carolina bays there. Give me your thoughts in the comments. All right, take it easy.